Hi everyone, now we are at Integral Calculus lecture number 8. So continuation to the last lecture, lecture number 7, we are at application number 2. It's about finding the volume beneath the surface. Let us do one more problem. Find the volume of the tetrahedron bounded by the coordinate surfaces 0, y0, z0 and the plane x by a plus y by b plus z by c is equals to 1. Now let us sketch uh, the region first. Okay, yeah, so now here x is 0, y is 0 means they are not lines, they are planes because we are in 3D. So x is 0 means, so let's take this is x axis, okay, this is y axis and this is z axis. Okay, now x is 0 means what? So this is yz plane. Yz plane means this is x is 0. This equation is x is 0. This plane equation, yz plane. Okay, yz plane. Similarly, this plane is z is 0. Z is 0 means indirectly in this plane, xy plane, z coordinate is absent in this. That means if you want to give one point on this plane, it should be like, for example, 1 comma 2 comma 0 like this. That means what? Z coordinate is completely absent. That means this point belongs to xy plane indirectly. Okay. Similarly, this one y is 0. In this, y coordinate is absent. Only x coordinate is present and z coordinate is present. Here also x coordinate is absent. Only yz coordinates are present likewise. Okay. Now, so now three planes are over. X is 0 is over, y is 0 is over, and z is 0 is over. I need to find the common portion, right? So x is 0, y is 0, z is 0. So the portion which is bounded by these three planes and the plane x by a plus y by b plus z by c is equals to 1. That means this plane intersect x axis at, so x axis at a comma 0 comma 0 and this plane intersect y axis at 0 comma b comma 0 and the same plane intersect z axis at 0 comma 0 comma c. Okay, now since this is x axis, therefore let us call this point is, this is a comma 0 comma 0, a comma 0 comma 0. Okay, and this point is, since it is on y axis, therefore 0 comma b comma 0. Let's call. Okay, and this is z axis, therefore this point is 0 comma 0 comma c. Let us take these 3 points. Okay, 3 points I have taken on the lines x axis, y axis, z axis. Now the surface, what is the surface now? So this is a surface passing through these 3 points. Okay, now this is the plane which is intersect x axis at a comma 0 comma 0, y axis at 0 comma b comma 0 and z axis at 0 comma 0 comma c. Now look at the plane, this plane intersecting yz plane at which portion? At this portion, right? So it is intersecting at this portion, so this one. So this is a common portion. Okay, this plane intersecting x is equal to 0 plane at this portion, so therefore this is common. Next, this plane intersecting y is equal to 0, therefore common portion is this. So this is a common portion here. Okay, so this is a common portion here. Let me draw in a different color so that, so this is a common portion here. And next one, this is intersecting the same plane intersecting z is 0 plane is, therefore z is 0 plane, therefore the common portion is this. So this is a common portion. So overall what you will get? So this kind of figure you will get. So this is a tetrahedron. Okay, so this one is a tetrahedron, this is tetrahedron. So same kind of figure generates here. Okay, actually you look at here, this one is not a triangle. Actually it is a plane. It is a plane like this, so you'll get like this. So this is a plane, but if you take the intersection portion, this triangular kind of face you will get, this triangular kind of face. You look at once, I will show you. Now look at here, let us take one example, x by 2, okay, plus y by 2, y by 3, let us take, okay, plus z by 4, z by 4 is equals to 1. Let us take this one. So now this one, let's take in a different color. Yeah, yes. So next, so now this is a plane. Look at. So just now I told you it is not a triangular kind of face. So if it is, see clearly, now look at the equation. So this plane x by 2 plus y by 3 plus z by 4 is equal to 1 intersect this plane x-axis at 2 comma 0 comma 0, right? Look at this point is 2. Look at here 2 2 comma 0 comma 0. Therefore this is x-axis, and this y-axis, look at 3. It is intersecting y-axis at 0 comma 3 comma 0. This point is 3. The plane is passing through that point. Okay, which point? 0 comma 3 comma 0. Now look at z-axis, it is touching at 4. That means the plane intersect z-axis at 0 comma 0 comma 4. Look at it, touching at 4. So now the plane which passing through 2 comma 0 comma 0, 0 comma 3 comma 0 and 0 0 4 is nothing but this one. Now if you take the bounded portion, this look like a prism, so tetrahedron. Look at, let us take all the coordinate axes. X is 0, okay, and y is 0 and z is 0. Okay, now let us change the colors, all the colors. So now x is 0 is green and y is 0 some orange color, light orange, and z is 0. Z is 0, let us take this one. Fine. Now, yeah, yes, look at now. Look at. So this kind of portion we are getting. Look at this one. So this kind of triangular thing you will get. So if I make it opposite, now look at here. This blue one is z-axis, this red one is x-axis, and green one is y-axis. Okay, green axis y, red axis x, blue one is z-axis. Now this plane is intersecting at these points. Look at 2 comma 0 comma 0, 0 comma 3 comma 0, and this point 0 comma 0 comma 4. Now look at, it's look like a line, but it is not a line, it is a plane. Now look at this kind of, in the draw also it's look like a triangular kind of face. Why it is looking like that? Because of the intersection portion. Now look at, I'm making z is 0 is present. Z is 0 means what? XY plane. This below one is XY plane. XY plane means in this z coordinate is absent. Now look at y is 0. Y 0 means it is xz plane. Look at, it is xz plane. In xz plane y coordinate is absent. Okay, y coordinate is absent. Similarly, now x is 0. X is 0 means what it is? YZ plane. So this is YZ plane. In this x coordinate is absent. So if you take all at a time, then what is the intersection one? So the intersection one is nothing but tetrahedron. Look at this one. So your triangular kind of you are getting. This kind of only we are getting there. Look at, that's what I have drawn here, like triangular kind of face. So therefore the face is this triangular one, and this side you will get, look at this side also, this kind of shape you will get, triangular kind of, and this side you will get this kind of shape you will get. Understood? So that's what it look like a tetrahedron. Now the boundary region with is nothing but tetrahedron. Okay, so therefore this will be our common portion. Okay, so therefore this is a tetrahedron. Now we supposed to find volume of this tetrahedron. Now look at, so how to find volume of that? So double integration over the region R z into dx dy. So this is what application number 2. Okay, here what is z? Z is nothing but surface. So here we need to generate the surface equation here, right? So therefore the surface equation is, so this is our surface, right? This is our surface. So therefore this surface equation is, so from this only, from this let us modify this. So what will get? X by a plus y by b plus z by c is equals to 1. From this, what is z by c? Z by c is 1 minus x upon a minus y upon a, right? And z is equal to c times 1 minus x upon a, right, minus y upon b. Okay, so this is a surface. It's called z is equal to some function of x comma y. Okay, so therefore here the surface equation is z is equal to, what is that, c into 1 minus x upon a minus y upon b. So this is the surface equation. Okay, so therefore what will you get? So double integration z over r also required. What is this region of integration? Region of integration is, look at this is view from this, look at, so from here you look at what will be the shadow of this tetrahedron. You look at from here, this is a view from here, you see to bottom, what will get? The shadow of this figure is nothing but this triangular portion, right, which is in xy plane. So this one, understood? So this one is the, look at this one, this portion is nothing but shadow. Therefore this is our region of integration. Okay, this is our region of integration. So therefore I can call this one as, so region R. So this is my region R, this is my region R. So in this region you have to integrate. This is region of integration. Okay, so therefore R is nothing but that. So that is my R. Okay, and what is Z now? Z is nothing but c into, right, 1 minus x upon a minus y upon b into dx dy. Next we need to generate the limits, x limits and y limits. Now look at, x is varying in this direction and y is varying in this direction. Now let us take x is independent, x is varying in this direction, so this is origin 0 comma 0 comma 0. So from 0 comma 0 comma 0, from 0 comma 0 comma 0 to this point, right, this point, right. Now 0 to a, so therefore x limits are 0 to a. Here let me write here. So therefore region R limits, right, x is varying from where to where? 0 to a, right. Next corresponding y should vary in this direction, right, y should vary in this direction from here to here. That means starting from here, look at, starting here and ending to this line, starting here ending to this line, that means starting with x-axis ending to this line. Okay, ending to this line. But what is this line? Is not, is it same always? It is not same always. Look at, from here to here starting with 0 but ending to this point. But if I start here, it is ending to this point. So every time upper bound is changing, so therefore it's a variable upper bound. So therefore this line equation I want. So what is this line equation now? So this line equation is, since this line is passing through the point a comma 0 only you have to take. Why? Because in xy plane only you have to consider, in xy plane only, in xy plane it is passing through the point a comma 0 and 0 comma b. What is the line equation now? So simply the line equation is x by a plus y by b is equals to 1. So this is the line equation, coordinate line which is passing through the point a comma 0 and 0 comma b. So this line equation is this. Okay, so from this, how to find y? Okay, y limits. So y should vary in this direction, right? Y should vary in this direction. So therefore we are supposed to find y limits. So x by a plus y by b is equals to 1. Y by b is equals to 1. So from that, what is y by b? Y by b is nothing but 1 minus x by a. Now b you send to right hand side. So b is here. So therefore y is equal to this much. Therefore upper bound is, so what is lower bound? Lower bound is 0, right, for y, because it started with x-axis, right? Y should vary in this direction only. Y should vary in this direction. So starting with x-axis and ending to this line. But what is that line? B into 1 minus x upon a. Understood? So therefore now the integration carried out over such limits. Now since y is dependent, so first with respect to y, so y lower bound is 0 and for y upper bound is b into 1 minus x upon a. Okay, and for x is varying from 0 to a, and the integrand is, so the integrand is c into 1 minus x upon a minus y upon a. So first with respect to y, because y dependent, after that with respect to x. You carried out this integration, okay, simple one, first with respect to y, therefore y minus x into y by a minus y square by 2 into b, then apply the limits. After that you proceed with respect to x and apply the limit 0 to a, and you're supposed to get answer a b c by 6. So this will be the answer. You try once, it's easy one. The main thing is the region of integration, and the limits. After that you can proceed easily. Next one. So now in today's class we're going to discuss about next application number 3 and 4. First, application number 3. If f of x comma y is equal to rho of x comma y be a density function. The density function, density means what? Mass per unit area, that is called density. How the mass is distributed, the function gives how the mass is distributed in the xy plane only, in the xy plane, because it is f of x comma y. If it is f of x comma z, in the xz plane, like that. Okay, then the double integration rho of x comma y dx dy over the region R, region compulsory should mention. So over R, double integration dx dy, and the value m, which is the m is nothing but total mass. That is nothing but total mass of this plate or whatever region or whatever object, this total mass of this object, it gives that. This is about application number 3. Next, application number 4, center of gravity. Center of gravity, I will explain it geometrically. Let's look at the application. If f of x comma y is equal to rho of x comma y be a density function. Density function means what? It gives the mass per unit area, in the xy plane. Okay. Then the double integration of f of x comma y dx dy. F is nothing but what here is rho of x comma y. F means. So double integration rho of x comma y dx dy will gives you mass of this object R. Right? Remember, double integration, depending on the application of double integration, depends on the nature of the function f. If f represents a surface equation, then this gives you value beneath the surface. If f is a density function, this gives you total mass of the object R. So depending on the nature of f only. Okay. Next, x bar object R. Here also over the same object R. Okay. And similarly, y bar is equal to 1 by m into y into f of x comma by dx dy. Here f means density function. Then this both the coordinates, the coordinate x bar, y bar, this one is said to be center of gravity of the mass m in the object R. Okay, that is called center of mass. Look at geometrically what is mean by both. Look at here, mass distributed uniformly. Now let us take this one, this object. Now in this object, look at mass is distributed uniformly. Wherever you take a unit area portion, small unit area portion you take, the mass is similar to the mass present here, which is similar to the other portions. Like for example, look at here. So I am taking a small portion, a unit portion, this one, a unit area. Let us call this unit area, and the mass which locates here exactly same as the mass which locates here. This is unit portion, unit area. Wherever you take, I am taking here small unit area. Wherever you take a unit area, the mass presents or locates in this portion exactly similar to here and exactly similar to here. That means what? Indirectly, the mass is distributed uniformly. Then for density function become constant here. So what is the density function f of x comma y? That will be constant. It does not depend upon the position x comma y. If x comma y changes, for example, at 1 comma 2, at 1 comma 2, at 2 comma 5, at 4 comma 5, like that you keep on change the location, then wherever you take, the density will be same. That's what I'm taking constant where k belongs to real number system. Density will not change. Similarly for this object also, wherever you take the unit area, the mass will be same. But whereas compared to here, look at here, if you compare to in this object, look at here, the mass is more compared to here, and here the mass is less compared to here. That means what? Mass is not distributed uniformly. That's what mass is not distributed uniformly. That means density function is not constant. If it is constant, what? If it is constant means what? Density. If it is constant, mass will be same at each and every unit area. But here is not like that. It's depending upon the position. So therefore it will changes. The mass is changes in every unit area. That's why it is a variable density function. It varies. The density function is varies in this case. So this is constant density function examples. This is variable density function examples. Now what is meant by center of gravity? Center of gravity, or in other words, simply the balancing point of the object. So for this object, what is the balancing point? Look at here. If I hold at this point, the object will stand. If I hold at this point, like your finger you hold like this. So this is a pen, look at, this is a pen. If I hold here at this point, then it will stand. It will stand. That means what? It is a balancing point. If I hold here, it will fall like this. So it is not a balancing point. Indirectly the balancing point here. So for this object, the balancing point is this. So that is called center of gravity. And for this object, the balancing point is this one. So therefore, if you hold here, it will stand. Otherwise, it will fall. Therefore, this is a balancing point. It is called center of gravity. Similarly, for this object, center of gravity is this point. If you hold here, it will stand. Look at this and this object, first one and third one. First one exactly midpoint you are taking, exactly midpoint. And here you are not taking midpoint. If you take midpoint, this will be the midpoint. If you hold here at this point, then it will not stand, it will fall. Why? Because here the mass is not distributed uniformly. That's why the position is changing. But here mass is distributed uniformly in the first object. So exactly midpoint will be the center of gravity. Now let us enter into some problems. Problem number 1. It's about variable density function. A thin plate covers the triangular region with vertices 0, 0, 2, 0 and 0, 2. And the plate's density at the point x, y is rho of x, y is equal to x, that means what? Density is changing. So it is not uniformly distributed. It is not uniformly distributed, right? Then find the total mass, capital M, and the center of gravity, x bar, y bar. So total mass I need to supposed to find, and center of gravity, which is x bar comma y bar. So these two we supposed to find for this plate. Now let's look at, just draw the graph first. So just call it as x and this is y axis. Okay, so this is x axis and this is y axis. Okay, now let us mark the points. So first one is origin 0, 0. Therefore this is 0, 0. And next one 2, 0, which is on x axis. So let us take this is 2, 0, 2, 0. Next point is 0, 2, which is on y axis. So this is 0, 2, which is on y axis. Okay, now let us add all these 3 points so that you will get a triangular kind of portion. So this plate, for this plate we need to find the entire mass and as well as center of gravity. So this is our required plate. So which is triangular plate, right? The shape is triangular and the mass is not same. it's not uniformly distributed. Look at it, a variable density function is given to us. Okay, somewhere thickness and somewhere very thin, such kind of plate it is. Okay, and for this plate we need to find total mass and center of gravity. Okay, now let us proceed. So first total mass m, which is given by double integration rho of x comma y, right? It is a density function of that plate over the region R into dx dy. So in this two things we know, first one is density function I want, right? First density function I want, next one is region I want. So here density function is already given, so this is our density function, rho of x comma y is equal to x into y. No problem with this, but I want the region now, right? So this region, so for that let us find this equation, line equation. What is this line equation? Same, this line is passing through x-axis at 2 comma 0, y-axis at 0 comma 2. Therefore this line equation is, this line is x by 2 plus y by 2 is equals to 1, or simply I can say that r x plus y is equals to 2, whatever. Okay, so therefore this is equivalent to, yeah, so that is the region, this is our region. So let's call this is my r, this is my r. So double integration, what is rho of x comma y, x into y dx dy. Next we're supposed to find the limits. Okay, now so x limits are 0 to, let me write here. So x limits are where to where, 0 to 2, 0 less than or equals to x less than or equals to 2, because x is varying horizontally, x is varying in this direction, and y should vary in vertical direction because this is y axis, that's why vertical direction. So starting with this line and ending to this line, this is ending line, starting here and ending here, starting here and ending here. So lower bound is x-axis and upper bound is this line. That means what, this line, upper bound is this line and lower bound is x-axis. Since lower bound is x-axis, therefore on x-axis y coordinate is absent, therefore starting with 0. Upper bound is this line is not point here, so therefore y is equal to 2 minus x indirectly, right? So therefore 2 minus x, so this will be the upper bound. So with this set of limits you can carry out the integration so that you will get the total mass. Okay, so therefore over the region R. So here let me write the R regions, R limits. So this will be exactly equals to double integration, right? Since y is dependent here, first with respect to y, so y is running from 0 to 2 minus x, 2 minus x, and x is independent, therefore with respect to second, 0 to 2. Okay, this is region R. Okay, now what is the integrand x into y? So first with respect to y, so dy first. Okay, after evolution with respect to y, then later we supposed to evaluate with respect to x, dx. That's it. So therefore this is equals to, yeah, let me write this. Yeah, so therefore x is running from 0 to 2, and with respect to y we supposed to evaluate as x into y square by 2, and the y limits are from where to where, y limits are from 0 to 2 minus x. So therefore x is from 0 to 2, x is from 0 to 2, x by 2 is irrespective of substitution of the limits, then send out. So 2 minus x whole square minus 0 square, this is after substitution of the upper and lower limits. Okay, and after that with respect to x we supposed to evaluate, so dx. Okay, and expand it, what will get, so x is from 0 to 2, x limits are 0 to 2, and expand it, x by 2, and inside a minus b whole square, so a square plus b square minus 2ab minus 4x into dx. Okay, then this will be x by 2 into x square, x cube by 2, right? So 0 to, x is from 0 to 2, x cube upon 2, then simplify x cube, so x power 4 by 4 to the 8 after evolution, minus 2x square by 2, 2 to cancel out, minus 2x power 3 by 3. Okay, and the limits are running from where to where, 0 to 2, 0 to 2. Okay, and substitute the limits. 2 to the 4, 4 to the 8, 8 to the 16, 16 by 8 is 2, minus 2 to cancel out, x square means 4, minus 2 into 2 to the 4, 4 to the 8, 8 to the 16 by 3, okay, and simplify this one, so minus 2 minus 16 upon 3, okay. So here you are getting negative, so total mass cannot be negative. There was somewhere you have done some mistake. Let us go back. Yeah, this is plus, right? So yeah, so this is plus here, right? This is plus, this one is plus, and this is plus, right? And this is plus. That's what. So 4 plus 2, 6. Okay, this is 6. So 6 minus 16 upon 3. Now what will get 18? So 2 upon 3. So this much. This is mass. Okay. So therefore mass will be this much. Mass of the triangular portion. Right. Next, what I want? I want center of mass. Center of gravity. Okay. So this will be x bar is equals to first coordinate x bar. So 1 upon m double integration over the triangular pit R y into f of x comma y dx dy, where f of x comma y is a, what is this? This is the density function. So this will be, so 1 upon m. So 1 upon m means here 2 by 3. 2 upon 3 double integration y into what is f is here? F is x comma y, the density function, right? Into dx dy. Okay. Now the same region R, same limit we have to supply here. So 1 upon, so 3 upon 2 here. 3 upon 2 double integration. Yes, now. So y limits are now from where to where? 0 to 0 to is 2 minus x, right? So it is 2 minus x. And x limits are from 0 to 2, right? And what is the integrand now? Integrand is x into y square. So since y's are dependent, so first with respect to y, so after that with respect to x. Okay, so with respect to x. Okay, so therefore 3 upon 2, now evaluate the integral. So first with respect to y, therefore integration x is from 0 to 2. So inside x into y raised 3 by 3, x into y raised 3 by 3, and the limits are from 0 to 2 minus x into dx. Okay, so which is 3 upon 2, right? Now integration x is from 0 to 2. Yeah, this one x by 3 I am writing completely outside, and inside 2 minus x whole cube, 2 minus x whole cube minus 0 into dx, right? We're supposed to find this one. So next one, the next page. So 3 upon 2. So 3 upon 2 integration 0 to 2. Okay, x upon 3 integration 2 minus x whole cube minus 0 into dx, isn't it? So this is equals to 3 upon 2 integration 0 to 2. Okay, now expand it. So x upon 3 a minus b whole cube, a cube, so 8 minus b cube, x cube, right, minus 3a square b. So 2 to the 4, 4 to 4 is 12. So minus 12x minus 3a square b. A is 2, b is x, minus 3a square b. So 2 to the 4, 4 is 12, 12 into x, right? And plus 3ab square, 3ab square, 6x square, ab square, okay, into dx. So 3 by 2 into, yeah, evaluate the integration. So 8x by 3, so 8 by 3 x square by 2, okay, x square by 2. Next, minus x power 4, so x power 5 by 5, 5 3 is 15, right? Next, minus 12 by 3, so 4 x square, x power 3 by 3, Next 3 2s are, so 2 into x cube x power 4 by 4. So after this we have to supply the limits. X is from 0 to 2. So simplify this. So 3 upon 2, right? So 2 to the 4, so 2, 16 upon 3, right? Minus 2 to the power 5, 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32. So 32 upon 15. We'll simplify this later. And minus 2 to the 4, 4 to the 8, 8 4s are 32, 32 upon 3, right? Plus, and 2 times get cancelled, and 2 to the power 4, 2 to the 4, 4 to the 8, 8 to the 16, 16 by 2, 16 by 2, and lower limit. So take LCM. So what will be LCM? 3 1 the 3 5. So 5 to the 15, 15 to the 30. So 30 will be the LCM, right? 3 tens are, so 160 minus 15 to the 64, 15 to the 32, 30 to the 64, minus 3 tens are 10, so into 32 320, right? And plus 2 15s are 15 into 16 240, right? And simplify this. So this will be 3 upon 2, right? So inside, so 30, denominator is 30, and numerator 160 minus 320, so minus 160, minus 160 minus 64, minus 224, minus 224 plus 240, so 224, 16, right? So 16 by 30, 16 by 30, and simplify this. So 2 ones are 2 8s, right? So 2 ones are 2 8s, and 3 ones are 3 10s, right? And again 2 table, 2 4s are 8, 2 5s are 10, so 4 by 5. So first point is 4 by 5, x bar is 4 by 5, okay? So therefore x bar is 4 by 5. So therefore x bar first point 4 by 5. Similarly you compute what is y bar. So next y bar is what is second point? Y bar is 1 upon m, right? Double integration x into rho of x comma y or f of x comma y. It has to be density function, and dx dy, okay, over the region R. Now this will be, so 1 upon m, so it should be 3 by 2, 2 upon 3 reciprocal at 2 by 3, so double integration, and x is from 0 to 2, right? And y is from 0 to 2 minus x, 0 to 2 minus x, and x into y. So first with respect to y, after that with respect to x, okay? And simplify this. So 3 upon 2, okay? So 3 upon 2 double integration, x is from 0 to 2, x is from 0 to 2, and y limits first. So with respect to y we have to evaluate, then evaluate it. So x square y square by 2. With respect to y we are evaluating because y is dependent here, and after that y limits we are supposed to run 0 to 2 minus x, 0 to 2 minus x into dx, okay? And this will be 3 upon 2, and x limits are 0 to 2, yeah. So x square by 2 is completely outside, and here 2 minus x whole square, 2 minus x whole square 4 plus x square minus 4x into dx, okay? And this will be 3 upon 2, yeah, evaluate, it is x power 2 by 2, right? X power 2 by 2, so 2, so inside 2 into x square, so x power 3 by 3, right? Next x power 4, so x power 5, x power 5 by 10, 5 into 2 10, evolution of that integral. Next minus 2 will be out, x power 3, x power 3, x power 4 by 4, right? X power 4 by 4, and we're supposed to apply the limits. X is from 0 to 2, 0 to 2, okay? So simplify this. 3 upon 2, yeah, upper limit, so 2 upon 3 into 8, so 16 upon 3, 16 upon 3 plus 32 by 10, isn't it? 4 to the 8, 8 to the 16, 16 to the 32, yeah, minus, and 16, so 4 4s are 4 to the 8, and the limit is 0, and take this and simplify. So let me go for next slide. So 3 by 2, so 3 by 2 into 16 by 3, 16 by 3 plus 32 by 10 minus 8, and simplify this. So take LCM, which is 30, 3 tens are 30, LCM is 30, and 3 tens are, so 160 plus 10 threes are 96, right, minus 240, because nothing is there, 1, so 130, 8 3 is 24. Okay, so now this one, so 3 upon 2, here 160 plus 96, 256, so 16 by 30. So now again same, 3 ones are 3 tens are, right, and 2 ones are 2 eights are, and 2 fours are 2 fives are, so 4 by 5. So same point I got here. So therefore y bar is also same. So y bar is 4 by 5. So now overall comment is, so therefore center of gravity is, center of gravity, so that is a balancing point indirectly, is x bar comma y bar. Okay, this is nothing but 4 by 5 comma 4 by 5. X bar I got 4 by 5 and y bar also I got 4 by 5. That means you take the triangular plate, this kind of triangular plate, right? So for this triangular plate, so this point will be 4 by 5 comma 4 by 5. So this is the balancing point for the triangular point. So assume this point is 4 by 5. So this is 4 by 5 and this is 4 by 5 and this will be 4 by 5. It is not exactly middle. Why? Because it is not uniformly distributed plate. So somewhere come down, right? So this is a point. So this point is called x bar y bar. So that is a balancing point. Okay. Next one. Problem number 2. For constant density function, find the total mass of a uniform or homogeneous density given density region which is lying between the parabola y is equal to 4x minus x square and the line y is equal to x. So now here uniformly distributed plate object. Okay, now let us sketch first. So this is x-axis and this is y-axis. Okay, now let us sketch first this y is equal to 4x minus x square. This is not a standard curve. Okay, so let us sketch now. How to sketch? So first you take so y is equal to 4x minus x square, right? So let us take one by one. So first x is 0. If you take x is 0, then what is y value? Y is also 0. Therefore the point is, what is the point? 0 comma 0, isn't it? Next you take x is 1. If you take x is 1, substitute here x is 1, you get y is 3. So therefore now the point is 1 comma 3. X is 1, y is 3. Next let us take x is 2. Okay, and what is y value? Y value, x is 2, 4 to the 8, 8 minus 4, 4. So 2 comma 4, 2 comma 4. Next take x is some 3. What will get? X is 3. Now y value, x is 3, 12 minus 9, 12 minus 9, it is 3. So therefore the point is 3 comma 3. Okay, then take one more point, touches x-axis. I think x is 4 now, 16 minus 16, 0. So y value is 0. Therefore the curve touches x-axis at 4 comma 0, like this. So that is enough. First let us mark the points 0 0. So this is the origin. So 0 comma 0, first point. Let us mark roughly 1 2 3 and 4. Just this is a rough sketch. Similarly 1 2, right, 3 and 4. If you don't know the shape of the curve, we can sketch like this. So first 0 comma 0 over, right? Next one, this is over. Next 1 comma 3, 1 comma 3, okay, 1 comma 3. Next 2 comma 4, 2 comma 4, right? 2 comma 4. Next 3 comma 3, right? So this point is 3 comma 3. Next 4 comma 0. So this point is 4 comma 0. Then add all those points so that you will get the required. First r is into this point. It is a curve, right? So it is a curve, therefore it has to bend. Okay, so this one. Okay, all these 4 points taken, 5 points I have taken. Next y is equal to xi1, right? Y is equal to x. So first let us find the intersection point so that from where the line is passing we can understand. 4x minus y square, 4x minus x square, and the line y is equal to x. So from these two I can say that x is equal to 4x minus x square. Okay, that means what? X square, I'm bringing this side, and minus 4x, so minus 3x is equal to 0. X square minus 3x, isn't it? So x is common, now x minus 3, right? So therefore clearly x is 0 or x is 0 or x is equal to 3. X is equal to 3. So if x is 0, then what is y value? If x is 0, y value. Substitute x is 0 in this, here on the line or on this parabola, whatever. So if x is 0, then y value 0. If x is 3, then y value 3. Okay. So therefore clearly the points of intersection here 0 comma 0, right, and here 3 comma 3. So already 0 comma 0 is this one. Next 3 comma 3 is this point is 3 comma 3. Therefore the line passing through these 2 points. So this point is 3 comma 3. Okay. Now bounded by this parabola, and this line is nothing but this portion. So this is a common portion. Okay. Now this is a region or object. So for this object we need to find total mass and uniform homogeneous density function. Uniform means mass per unit area for each and every unit area mass will be same. That means, so since, yeah, let me take the next slide. So since density function is constant, because why it is constant? Because mass distributed uniformly. Mass distributed uniformly. That's why density function is constant uniformly. Okay. So therefore clearly we can say that f of x comma y is nothing but rho of x comma y is nothing but rho of x comma y density function. This is constant. Let us write k, where k belongs to real number system, positive real number system, constant. Okay. So then what is the total mass now? So total mass m is equals to double integration over the region R, rho of x comma y dx dy, isn't it? So this will be, so double integration. Now what is the region here? Look at the region. So this will be the region. In this I want x limits and y limits. Let us write this one, and the region is R. So for R, what are the limits now? R, yeah, tell me, x limits, x should vary horizontally, right? X should vary horizontally, but you are getting two different kinds of limits for x. If you take x is dependent, you will get a tricky steps. Look at, for lower limit is green one, x should vary in this direction, right? X should vary in this direction, but up to this point, upper bound is this line, upper bound is this line only, y is equal to x. So this is y is equal to x. Let me write here, this is y is equal to x, and this one this is y is equal to 4x minus x square. Okay, and look at up to this point, right? So up to this point, upper bound is this line only, but after this upper bound becomes this curve. Lower bound is same curve, upper bound is same curve. So therefore, instead of taking x is dependent, let us take y is dependent. We will get a simple limits. Okay, so now let us proceed. X is independent and y is dependent. If you take y is dependent, what kind of limits we will get? So let us take y's are dependent, so therefore x is independent. So cleverly you have to choose the kinds of limits. Okay, now x should vary horizontally, so starting with origin 0 comma 0, so maximum point for x is 3. Is it 3? Maximum point is 5. X should vary in this direction, right? So only this is a boundary region, so maximum point is 3. If you take this entire thing is a boundary region, then maximum point is 4, but our boundary region is only this one, right? R1, shaded one. So maximum for x is 3, so therefore 0 to 3, x value 0 to 3. Corresponding y limit should be dependent, so y should vary vertically. So y starting with this blue line, therefore y is equal to x. So lower bound is x, upper bound is curve, this curve. What is this curve? 4x minus x square, 4x minus x square. So with this set of limits we can carry out the integration. So 0 to 3, x to 4x minus x square. So therefore 0 to 3, 0 to 3 and x to 4x minus x square. Okay, so these are y limits. Y is x to, y is equal to x to 4x minus x square. And what is rho of x comma y? It is a constant, so k into, so first with respect to y we supposed to evaluate because y limits are dependent, after that with respect to x. Okay, so therefore integration 0 to 3, integration 0 to 3, and so k into y, and limits are from x to 4x minus x square, after that into dx. Okay, now this will be, so k is constant, so we can drag out integration. So therefore integration 0 to 3, plug in back, so 4x minus, so k should out, 4x minus x square, this is upper limit, minus lower limit is x. Okay, into dx. Next step, so k into 4x minus x, 3x, so 3x square by 2, 3x square by 2 minus x square, so x power 3 by 3, and the limits are 0 to 3, 0 to 3. Okay, now this will be k into 3 upon 2, 3 upon 2 and 3 square, 9 to the 27 upon 2, so 27 upon 2 minus 27 upon 3. Okay, lower limit is 0. So k into, take LCM, LCM is 6. Okay, or you can take 27 is also out. Okay, 1 by 2 minus 1 by 3. So LCM is 6, 3 minus 2. 2 3s are, so 3 minus 3 2s are 2, so 1 by 6. So k into 27 upon 6. So if you want to simplify, you can simplify. So this will be 3 9s are, so 9 by 2 into k units. So if you take the density function is 1 constant, right, then it will be 27 by 6, that means 9 by 2 only. If we take density function is some 2, that is constant only, right, everywhere it is 2 units only, then 2 into 9 by 2, that like that you will get. So 9 by 2 into k units. So this is total mass of such a uniformly distributed plate. So similarly, problem number 3, for constant density function only, find the center of gravity of total mass. Center of gravity, you need to find center of gravity of total mass of a uniformly or homogeneous density object which is bounded by x square plus y square is equal to 4 and y is equal to minus x and y is equal to 0 in the second quadrant. In the second quadrant, how it looks like? First let us sketch the region. Let's take this as x-axis and this is y-axis. Okay. First, x square plus y square is equal to 4. Center is origin 0, 0 and radius is 2 units. Okay. So radius 2 units and center is at origin. Assume z of 1. Okay, assume the center is origin and radius is 2 units. Okay. So, and next y is equal to minus x. Y is equal to minus x means this one. So this is y is minus x. This is y is equal to minus x. Right. Next y is equal to 0 means what? It is x-axis. So this x-axis. So bounded by circle, this line and x-axis in the second quadrant. Therefore, this is a required region. The second quadrant, which is bounded by x-axis, this circle and y is equal to minus x line. So in this region, we supposed to. So this is our required plate. So for this region, okay, for this object, we need to find center of gravity. Okay. Now how to find center of gravity for this? So first I required mass, right? So what is the mass now? Mass is equals to double integration over r rho of x comma y dx dy. Okay. Here it is given that it is a uniformly density object. So therefore, let us take the density is k. Okay. So therefore, so particularly change the problem. Density uniform homogeneous or uniformly density with one you take. Rho of x comma y is equal to 1 you take, including the problem. So I am taking density function is 1. So therefore this become, so double integration over r. So rho of x comma y is 1 into dx dy, and this is r. So since it's a kind of, it's a part of circle, so I can approach to polar coordinate system. So you can evaluate easily if you approach to polar coordinate system. So therefore, so let x is equal to r cos theta, and y is equal to r sin theta. Okay. And what is dx dr? Dx dy is r into dr d theta. Or if you don't want to approach polar coordinate system, directly you can evaluate, no problem. So now x limits are minus 2 to 0. What is this point now? So this point is minus 2 comma 0 because radius is 2 units, right? This is minus 2 comma 0 because it is on negative x-axis, and this is 2 comma 0. This is on positive x-axis. If we take y's are independent, then y should vary vertically in this direction, right? So starting with this 0 and ending to this line. So this point of intersection I want, this line and circle. So line and circle means y is equal to minus x, substitute here y is equal to minus x. Then what will you get? Y is equal to minus x. So 2x square is equal to 4. Therefore x square is equal to, so plus or minus root 2. Therefore this point is root 2 comma root 2. X is minus root 2 and y is plus root 2. So therefore y varying from 0 to root 2. You can take root 2. And x should vary horizontally. So starting with the curve ending to this line, starting with this curve. So therefore this blue one. So therefore lower bound is 4 minus y square. 4 minus y square. So square root over 4 minus y square. Upper bound is line. So minus y. So this one. Okay. So therefore with these limits you try, you can get it, or you convert to polar coordinate system. If you convert into polar coordinate system, you get easily. So therefore this integral becomes r into dr d theta, the corresponding r and theta limits we want. Since this is a region of integration, right? So now radius is varying from where to where? 0 to minus 2, but I should not say minus 2 because radius is positive. I have to write r is 0 to 2, positive. Okay. Corresponding angle, so this is 0, it is pi by 2, and this is, since it is y is equal to x, therefore this angle is 45 degrees. So pi by 2 plus pi by 4. How much? 3 pi by 4. So this up to this is 3 pi by 4. 3 by 4 plus pi by 4, you will get pi. So now angle is from where to where? 3 pi by 4 to pi. So angle theta, so theta is 3 pi by 4 to pi. 3 pi by 4 to pi. Okay, because from only this one I want, right? R is a shaded one. So from here to here only. So 3 pi by 4 to pi. So without evaluating this, let's guess what is this portion, what is this area indirectly. Mass is nothing but here area. Now entire circle area is pi r square. Since radius is 2, pi r square, so 4 pi. So 4 pi is the total area, right? Now we have to divide into 4 equal pieces. Therefore, here is pi, here is pi, here is pi, and here is pi. In the second quadrant, total area is pi units, but again you have to divide into 2 pieces. So pi by 2. So this portion is pi by 2. I suppose to get pi by 2. Let us verify. So now this will be first, since both are independent limits, you can evaluate first with respect to r or first with respect to theta, your wish. I am evaluating first with respect to r. Okay. So now it is r square by 2. And r limits are where to where? 0 to 2. After that, I have to evaluate with respect to theta. Theta from 3 pi by 4 to 3 pi by 4 to pi. Okay. Into d theta. And this will be exactly equals to, so r square, so 4 by 2. So 2 d theta. And limits are 3 pi by 4 to pi. 3 pi by 4 to pi. Okay. Now what do you get? 2 into theta. 2 into theta, and theta limits are pi minus 3 pi by 4. So pi minus 3 pi by 4, how much? So 4 pi minus 3 pi. So pi by 4. So 2 into pi by 4. So how much you got? Pi by 2. That's it. Pi by 2. So therefore total mass is, so therefore mass m is equals to pi by 2 units. You can write mass units, pi by 2 units. Okay. Like similarly, you can find the what center of gravity. How to find center of gravity? Center of gravity. So it is x bar and y bar. Okay. Center of gravity, which is x bar and y bar. So first, what about x bar? X bar is nothing but 1 upon m double integration y into density function rho of x comma y dx dy. Okay, and over r. So same story, you proceed this. So 1 upon m, so 2 upon pi, right? Double integration. Again r is from where to where? 0 to 2, and theta is varying from 3 pi by 4 to pi. So if we convert into polar coordinate system, our job become easy, so easy. So y into, so now y means r sin theta. I am completely converting into rho of x comma y is 1, right? 1 into dx dy means r dr d theta. Dr d theta. Take it exercise, proceed. So now what we understood is, so if I want to find center of this portion, this sector, center of this sector, simply you proceed to the center of gravity concept. For example, look at this kind of graph I am having. For example, look at this. Now this is a scheduled, so this is a required one. Okay. Now for this region, this will be the, what is the center of gravity? So what will be the center? So for that, what I have to take is density function. You should take as 1. Uniform density function, and particularly density function should take it as 1, and proceed by the concept of center of gravity, so that you will get center for this object. Center for this object. The concept is true if you take uniformly distributed density function, and particularly that should be 1. Okay, so this is the main application of finding center of some irregular figures. For example, they are having a right angle triangle. How to find center for this right angle triangle? You take density function is 1 and proceed by the concept of, center of gravity, so that we get center for this triangle. Okay, so with this I will stop, and let us take few exercise problems. 4 exercise problems, and complete this, and with this I will stop.